I'm going to explain here another video which is just a bit more complicated than before, the ones before. I have here a rational expression and I have a root in here in this rational expression with it's in the denominator. Let's see how we can work this through. Well, the thing is here that you have to split this problem. You have to divide this one, and there will be one problem for the denominator and another one for the denominator. And then once you got the restriction for the domain, you will see how they fit them together. So I think we better just get started here, and let's see how we feel about it. So I'm going to start with the easy part, which is this one here, the one in the denominator. As this is a rational expression, what's a denominator cannot be equal to 0. So I'm going to write it in here, will be x minus 8, different from 0. So x has to be different from 8. That was easy. Now I'm going to get with what's in the root. Now in the root, we have to make sure that what's inside the root has to be greater or equal than 0. So it will be, I'm going to write here both factors, x minus 3 and x plus 6. And they are greater or equal than 0. Now I'm going to take each of them and separately I'm going to equalize them to 0. X minus 3 equal to 0. 0, and here will be x plus 6 equal to 0, and then I will solve both x's. Here will be x equal 3 and x equal negative 6. Now here I'm going to place both values of x in my nice graph here on the right. I'm going to write it in here, will be here the negative 6, and I write here the number 3 here. I'm just actually going to leave more space here. Now again, I have to place the big values for, the intervals here from negative infinite until negative 6, and for the values in between here from negative 6 until 3, and for the values after the 3. So I'm just going to pick the simple values here. I'm going to pick x equal to negative 10. I'm going to pick here x equal to 0, and here I'm going to pick, I don't know, x equal to 10. I think just the simplest cases here. Now I'm going to substitute these values on the original statement. I'm going to substitute the negative x. I'm going to use here again yellow here. I'm going to substitute the negative 10 in here, and then I will get negative 10 minus 3 times, actually I'm going to write it, I need a bit more space. I'm going to write it here, negative 10 minus 3 times the negative 10 plus 6, it is greater or equal than 0. So I got here the negative 13 times negative 4, it is greater or equal than 0. Now again, we have to be only concerned with the signs here. It will be negative times a negative, and we have to ask, is this greater or equal than 0? Well, actually, yes, it is. That is to say, we get inside the root a positive number. So for any value we pick from negative infinite onto 6, we'll always get a positive number. So we include this interval here. Now I'm going to do the same with the value of x equal to 0. I'm going to substitute it here with this in the inequality here, only in the inequality here, and I'm going to get here will be 0 minus 3 times 0 plus 6, is this greater or equal than 0? Well, I get here a negative 3 times a 6 is greater or equal than 0. Now we have just again to pay attention to what the signs are saying. It's a negative times a positive. Oh, positive like this, is this greater or equal than 0? Well, we have just to ask, well, this will always produce a negative number, so this will fail here with this greater or equal than 0, and we do not include this interval from negative 6 until 3. I'm going to do the same with the last value of x here, with this x equal to 7. So it will be here 10 minus 3 times 10 plus 6, this greater or equal than 0. I think you should be noticing where we're getting here would be here a 7 times a 16. Is this greater or equal than 0? Now we get here again with the signs. We only concern with the signs here. Time positive times a positive. This will always be greater than 0. So we pass the test and we include this interval here from 3 to infinite. Now here it would be wiser just to test what happens with the -6 and the 3. It will prove more useful in a future example, but I'm just going to do it here anyway. It would be -6 minus 3 times a -6 plus 6 greater or equal than 0. We'll get here a -9 times a 0 greater or equal than 0, and we get to this 0 greater or equal than 0. Yes, it is. It falls into the equal part of it. So we include the -6 in the result here. Now I'm going to do the same thing with the 3. This one here, I'm going to substitute it again in here. So we get here 3 minus 3 times 3 plus 6 greater or equal than 0. We get here a 0 times a positive 9. So we get us to, again, this 0 is 0 equal, greater or equal than 0. Yes, it is. So we included positive 3 in the solution here. Now, this is telling us that domain of this part, I'm going to write it here on the right just to make notice, I'm going to write it like here. Domain, I'm going to say here of the root, just to make clear that this is not, I'm not talking, when I'm saying here this domain of the root, I'm not talking of the whole expression of the whole f of x. I'm just talking of the root of this part. The domain of the root is telling us that you can put input values to that part of the expression from -infinite until -6 included, and we have to union it to from 3 to infinite. Now that would be the domain of the root. But we cannot forget about this x different from 8 that places, this restriction is placed by this x minus 8 on the denominator here. Because if we accept the value of 8, we will fall into a non-defined situation. That's the problem here. So we have to mingle all together all these restrictions. We have to mingle to put together this one and this one here in one big solution. I'm going to write it in here down on the left in orange here. The domain would be from -infinite until -6 included, union from 3 to 8. Here comes the difference. We exclude the 8 by using this parenthesis here. Then we use the union. We put again here the 8 here. We are again saying we're excluding the 8, and then until positive infinite, and we close these parentheses, and that will be all of it.